Assalamualaikum. Today we will discuss the rotation and unfold. In water, there is C2, and you can see here that C2 and axis and two fold 180 degree. After checking their diagram, we can see that the numbering in the hydrogen molecule will be inverted after 180 degree, and it will retain its original position after again 120 degree. So this is called as a C2 rotation, 360 divided by 2. Again, the discussion of ammonia molecule. In ammonia, there is a C3 axis with the angles of 120. Symbolical representation is N and H. Numbering are 1, 2, and 3. 4. As you can see here, the numbering will be changed from H3 and H2, and after 120 degree rotation, the molecule retain its geometry as the first one after C3 axis. So this is three-fold rotation, and the angle is 120. In the water molecules, one C2 axis and two middle planes are present. C2 axis and the plane of symmetry contains basically water molecule, and C2 axis and the plane of a symmetry that is basically perpendicular to the plane water, and plane of a symmetry in a molecule shown in below. In this represented for the water, which combines the diagram. As you can see here, A and B. Plane, there is a N4C2, and mirror plane, yeah, sigma V and sigma V dash, which show in the one combined pic in C in the figure. Now we can discuss the ammonia molecule. In ammonia molecule, as you can see here, there is C3 square and C3 cube, which is equal to the identity, and angle is 120. If I close this, you can see here the molecules of nitrogen is in the mid, and tetrahedral symmetry has 3, 1, 2, 3 numbering hydrogen, and from here they turn and rotated at 120 degree, again 120 degree, and again 120 degree. That's why it's 3 times 120 degree rotation. It's called as a C3. So successive C3 rotation in ammonia and C3, which is equal to the identity, you can summarize at C3 equal to C3 square is equal to C3 cube, and similarly, HCF4, which has one C2 axis which coincide the principal axis, and C4 axis, and C2 dash axis, and two C2 dash axis, and each two sigma planes, and you can see as their C4 axis and one C2 dash axis. Each 2 sigma 2 plane contains the C4 axis and one C2 axis. In the figure, you can see that this is basically is the molecule of HCF4, which has the different type of symmetries, vertical, and two C2 dash, and C2N, and sigma D dihedral. Now come, here is the PF3 molecule, which has basically is C2 and C3, 3-4 C3 and 2-4 C2 axis of symmetry, and which is the trigonal planar molecule. This is the structural of PF3. What is plane of symmetry? It basically reflects of all the part of the molecule through a plane, which can be produced indistinguishable, and the configuration plane is plane of symmetry, and the symmetrical operation is one of the reflection, and the symmetry element, which is basically is the mirror plane. In the molecule of a BF3, the plane consisting molecules, which is the framework, is a mirror plane. Second, the plane lies perpendicular to the vertical axis is sigma h. Molecules which are in the linear band or the planar are basically always drawn in plane, and you can also call it is basically is the sigma h, and 2. If molecule possesses Cn axis perpendicular to the plane, then the plane contains the principal axis, which is sigma v, and the special type of the plane, which contains the principal rotation but bisects the angle between the two adjacent folds, is called as the sigma d. So scale planar XCF4 show this symmetry. XA4 controls C4 axis perpendicular. There is a deflection plane which may be vertical, horizontal, and the dihedral. And you can see the successive reflection of the different vertical and the dihedral points, and sigma d and sigma d dash, sigma 4, sigma xy, yz, and sigma v. And here is the different type of distinguishing sigma d, sigma v, and sigma h vertical planes.